Today we are going to look at basically solving quadratic equations. Solving quadratic equations. Solving quadratic equations. Solving quadratic equations. So simply, when someone says quadratic equation, I don't know what simply comes in your mind, but what we ought to know is that for an equation to qualify to be a quadratic equation, its highest degree must be a 2. So if an equation lacks a highest degree of 2, then that equation ceases being a quadratic equation. So we shall simply look at all the possible measures on how we can tackle all equations concerning solving a quadratic equation, which may not look difficult but so simple. So always endeavor to make practice and perfect. The more practice you make, every topic you finish, make sure you do a variety of examples. So as we do quadratic equation, make sure you try to look out for my examples and try work down them for yourself and see how best we can go. So we said a quadratic equation, its highest degree is 2. What do I mean by a degree? So instead of using the word degree, I can use a power. So the highest power of a quadratic equation is power 2. So that's what I'm referring to as degree 2. So what you ought to know that all quadratic equations are in the form of ax squared plus bx plus c equals to 0, where this a is just a coefficient of x. So this is just a coefficient. So that number behind any unknown is called a coefficient, as well as b. B is also coefficient. So this quadratic equation, where you are saying it is a quadratic equation, reason being we said a quadratic equation has its highest power as 2. And we can as well notice that the highest power of this equation is a 2, then 1, then 0. What do I mean? This a is just a coefficient, mean that this equation is now in terms of x, where we see that x began with the power 2, then it reduced, this is just a coefficient, it reduced to power 1, and we know that anything power 1 is always that very thing. That's why I did not endeavor to put a 1 plus a c, where we see that this is just a constant. So c is just a constant. In other words, our x came from power 2, reduced to power 1, and went to power 0. And we know from indices that anything power 0 is always a 1. So it means that this x, since it is the power 0, it gave us a 1. And when we multiply the 1 times the c, we came back with a c. So that's how we write a quadratic equation. Simply that all quadratic equations should be in the form of ax squared plus bx plus c equals to a 0. So that's how we can identify that this is a quadratic equation. The highest power should always be a 2. Is it okay? So there are many ways of solving quadratic equations. Simply, we can use the bulldozer method. Bulldozer is what we call completing squares. Completing squares. There is factorization. Then there is also what we call the graphical method. The graphical method. So for this case, I will not first of all look at the graphical method. but I'll ideally show you how to use the other alternatives. Maybe in your free time you can get a graph and see how best you can go about how to use a graph and how to solve quadratic equations. So the bulldozer formula we can ideally generate and see how the bulldozer formula comes about. For example, we said all quadratic equations are in the form of x squared. So it's not a must that you always use x. So quadratic equation can be in any unknown, maybe in terms of m, any other unknown. But we have seen that all quadratic equations are in the form of ax squared plus bx plus c equals to a 0. So we can come up with a bulldozer formula. And the bulldozer formula is given by x equals to negative b plus or minus root of b squared minus 4sc over 2a. So we shall see how the bulldozer formula comes about. So I just wanted to generate and see how the bulldozer formula comes about. So the way you can generate that bulldozer formula you see above is by what we call completing squares. So how do we complete squares? It is simple. Always just look critically. Always the first step is this constant we said is first of all taken to the right hand side. So it crosses the equal sign. So we shall have ax squared. That is the first step. There is nothing confusing here. Just look critically. So that is our first step when we are completing squares. After that, we shall make sure that the coefficient on x squared is always a 1. So for this case, it is not a 1, it is a. The coefficient of x squared is a. So we have to remove that a and make sure the coefficient is a 1. How shall we make this coefficient a 1? We shall make this coefficient a 1 by dividing throughout by a. So that I will divide this by a. I divide this by a. I also divide this by a. Is it okay? So I'll end up having this crossed out. I remain with x squared plus bx over a equals to negative c over a. So that is the second step. So from there, after making sure that now I see that the coefficient is a 1, the third step will be look at always the position of the sum. So in the quadratic equation, as we have seen this is always the position of our sum. Where we see x being on degree 1 is always the position of our sum. So I can notify that this x is on degree 1 or it's on power 1. So I look at that position of the sum. So taking note of this, I will take away the coefficient excluding the x because our x is part of the quadratic equation. So I'll take the coefficient. So what is the coefficient of the whole of this? The coefficient is ideally b over a. That is the coefficient. So we have seen that our coefficient, looking at this sum, the coefficient is b over a. So after identifying the coefficient, we multiply that coefficient times a half. And when you multiply it by a half, remember when you're multiplying fractions, numerators are multiplied separately as well as the denominators. So we say b times 1, which is a b, over 2 times a, which is a 2a. We are looking at the position of the sum. We have obtained the coefficient, which is b over a. We have multiplied it by a half. And the answer we get, we have to square that answer. So I've squared that answer. So what do I do? After squaring this, I'll add the result I've got here and here. So I'll just have to repeat what I had. X squared plus bx over a. I'm repeating this. Then I just added the result I got here, which is b over 2a. squared equals negative c over a. I also add the result I got, which was b over 2a squared. From there, just do the algebra and we go. So, notifying that this is a squared and this is a squared, after identifying that this is a squared and this is a squared, we shall just simply consider a square. We shall consider this squared and that squared. Because this is squared as well as this, I consider the x. Take the first sign here, which is a positive. Then consider this one, b over 2a. Just square them at once. I'll show you how this comes about. Why do I say that? Just look at those which are squared and take the x and take this, then you square at once. Because when you expand this, we shall come back to this. I'll show you the reason why. So this is negative after generating our bulldozer formula. C over a plus, this is square the b. The square affects everything inside. B squared, then square 2 you get 4. Square a you get a squared. So this is our x plus b over 2a squared. We shall consider the LCM of this, which is ideally a 4a squared is our LCM. So this divided by this you get, so this divided by a. It's like we have 4a squared, we are dividing by a. So a squared just means a times a. So one a will go with the a, remain with the 4a. So this divided by this we get 4a. We have seen that. Then we multiply it by the negative c, we get negative 4ac. Then 4a squared divided by 4a squared, we get a 1 times that, we get plus a b squared. So that's what we have gotten. So we shall repeat this. B over 2a squared will give us, I can begin with this positive, b squared minus 4ac over 4a squared. From there, the only way we can make this x the subject is by taking the square root on both sides. I know the square root result is either positive or negative, so the square will cancel out with the square root. We remain with our x plus b over 2a equaling to a plus or minus. This upper we cannot get the root. Reason being, we have an operation sign, the negative here. So that ceases, we leave it the way it is in a square root. Don't tamper with anything. Over for this, we can get the square root. The square root of 4 is a 2, and the square root of a squared is a. So from there we can just make x the subject of the formula. How? We carry this side and we bring it here. It becomes a negative b over 2a plus or minus root of b squared minus 4ac over a 2a. But we ideally know, if the denominators are the same, we just maintain the denominator and then we deal with the numerators. So ideally we shall come to an expression we always see as the bulldozer formula, which is x will equal to negative b plus or minus root of b squared minus 4ac over a 2a. So we have maintained the denominator. I think you can see that the 2a is common. We maintain that denominator as we have done here. So that's what we call the bulldozer formula. Then I promised to explain the reason as to why I just said when I see a squared here and a squared here, I just say squared, I consider the x and I consider the b over 2. Well, how does it come about? So I think you have ever seen something of this sort, where we see that we have a plus b squared, or it can be a minus b squared. So I think you have ever seen these two things. So when we are expanding this, some people can do it in a different way. As you know, mathematics, same different ways, same answer. Someone else can say that when I have a plus b squared is the same as saying a plus b into a plus b. Reason being, it is repeating itself twice. It says a times a, it gets a squared. Whenever you multiply something which is the same, just get that thing squared. Then a times b, we get plus ab. Then go to this, we also multiply the whole of this. B times 8 is the same as still a b. B times b, since it is b and b, we get a b squared. So if this is a mango and this is a mango, we shall get two mangoes. So we just have a squared plus 2ab plus b squared. So that's what we are having. So some other people, so that is always the expansion we have. So we have seen how that has come about. It has come from this. So ideally, some people don't even take their time, just to say they have it in mind. When I have this plus b squared, it will always give me this squared, which is a squared. Then 2 times a times b, which is the 2ab. Then lastly the b, I square the b. Are you seeing that? So we shall come up with the same answer. Just to know, square this, 2 times this times that, then the b squared. So whenever you see a squared here and a squared here, what do? We just take this a and take the b, then we square at once. That's what we did here. After seeing the x squared here, and after seeing the b over 2a squared, we just consider the x and we also consider the b over 2a, then we just squared at once. So that originates from this. So as well as you have, when you have a minus b squared, it will as well give us, you square the a, it becomes a squared. Then the 2 times this times negative b, it gives us a negative 2ab. This times that, negative 2ab. Then you square the b, which is when you square a negative, you come back with a positive. So as well, whenever you see this squared and this squared, you just take this a here, you also take the b there, then you take the first sign. So for that case, it is a negative, then you square them at what? So it is just the same. So that's why we had to just consider the x and the b over 2a, then you square that at once. I think you have seen where it originates from. So that's how it originates. So we shall look at our first example, and we shall use the 3 methods. So I think we have come finally to see how the bulldozer formula comes about. So I'm going to give you one example, and I'll roughly use all the 3 methods, excluding the graphical, which is the 4th. You'll do it using a graph. It is just a matter of plotting. So I can take an example, the first example here. So given number 1, we are solving quadratic equations. So 4y squared minus 48y equals to a 16. You remember we said all quadratic equations have the highest degree of 2. So looking critically, I'm seeing our unknowns. For this case, it is no longer x. The unknown is y. So don't stick in mind that it should always be x. Next time they can bring m. Next time they can bring n. So keep in mind that these are just unknowns. Just keep in mind that always a quadratic equation has a highest degree or has a highest power of 2. So this is a quadratic equation, but make sure whenever you see a quadratic equation, it's upon you to see that it is in its simplest form, and make sure that always it is arranged properly. So for this case, I can arrange this quadratic equation and I can put it to its simplest form. Seeing critically, all these numbers are divisible by 4. So I can first of all reduce them and divide them throughout by 4. When I divide this by 4, I get, so I'm dividing throughout by 4. Even here I will divide by 4. I can also divide this by 4. So this will give us y squared minus, this is a 1, 2, so equals to 4. I've reduced this to its simplest form. I can arrange this quadratic equation so that it is suiting the expression that says that since this is a y, they should be in a form of a y squared minus b plus by plus sc equals to a 0, which is the same as some people which say ax squared plus bx plus c equals to 0. Why did I use y? Because they had used y. So it has to be in this form where we see the highest degree 2, from degree 2 to degree 1, and finally to a constant. So in the first example, I first of all simplified that. But since I'm going to use the first method of factorization, the first method I will use is factorization. I forgot to tell you. So our example was that, but I'm going to use factorization. So when I'm using factorization, I should always make sure that it is in its simplest form, and I'll always arrange the quadratic equation in the form of this. So I will say this is my degree 2. I'll put the degree 2 first, followed by degree 1, which is a negative 12y. Since our 4 is a constant and is to degree 0, we said anything power 0, it would have been y power 0. So from degree 2, degree 1, then degree 0, but anything power 0 is always a 1. So I'll just take this one this side, my constant, it becomes a negative 4, because all quadratic equations must equate to a 0 when I'm solving. So it is equating to a 0. So we can ideally see that it is in the first form. We said ax squared plus c plus bx plus c equals to a 0. So I've arranged that quadratic equation. So having arranged that quadratic equation, let me see how best I can go about this. So we said I'm using factorization. So whenever I'm using factorization, I'll use what we call factors. So we say this one is the position of the sum. That is the position of the sum. But always the coefficient here and the constant, when we multiply these two coefficients, this coefficient here and the constant, they give us our product. But this position here is for the sum. So ideally, for this case here, the sum is a negative 12. So the sum is a negative 12, whereas the product will be this one, which we cannot see, times a negative 4, which will give us a negative 4. So you should always have to put in mind that not all equations can be factorized. So for this case, they have given us this equation, but you cannot use what we call factorization. Why do I say that you cannot use factorization? Because for factorization, we get two factors where we shall multiply those factors. When we multiply them, we get the product, and when we add them, we get the sum. So this case, factorization is out. So let me go to bulldozer. How will I use the bulldozer? You remember the equation was arranged as y squared. Our equation is y squared minus 12y minus a 4 equals to a z. So you can either use bulldozer or completing squares. So let me use the bulldozer formula, which is in the form. So instead of putting x, since the unknown here is y, I will use a y. Is it okay? Or you can first write it the way it is, plus this b squared minus 4ac over a 2a. take note that this is not x we are having a y, so this will equal to neg a. So our y will equal, so instead of putting x I put a y, equals to negative b plus or minus root of b squared minus 4ac over 2a. But we know, according to the quadratic equation, the coefficient on y squared is our a. So I can identify that a is a 1. Then our b is this, the coefficient on a y. So our b will be a negative 12. We had arranged this initially before. Are you seeing the position of a? Do you see the position of b and this is the position of c? So that's what we have done here. So our a is a 1, our b is a negative 12, whereas our c is a negative 4. So our c is a negative 4. From there I just substitute in the bulldozer formula. So I just come and I say my y will equal to, where there is b, I substitute in for b. Our b was negative. Leave this negative. I can ideally tell you substitute with a bracket for simplicity. Plus or minus root of b is negative 12 squared minus 4. What is our a? It is a 1. What is our c? Negative 4. So for simplicity you can use brackets. So 2 and our a is a 1. So our y will equal to negative times the negative, we get 12 plus or minus, this is, when you square 12 you get 144 minus a negative times a negative, we get a 4. This times this, we get a positive. 4 times 4, 16 over our 2. So our y will equal to 12 plus or minus. When we sum up with that, what do we come up with? So we have to sum up with that. So you can use your calculators and make sure you finalize this number. So from there, you first of all consider the positive first, you get the first answer. Then you consider the negative next, you get the second answer. So for this case, you should just add this to that. This and this is a 10, 6, then a 1, 160, then over a 2. So from there, use your calculator, get the positive answer. Then you consider the positive first, you get the answer. Then from there, you can consider the negative and you get 2 answers. So for this case, since we have just looked at briefly how quadratic equation looks like, as we come to the next tutorial, like how we shall look at more examples, this has just been an introduction, and I've just been briefing you how simply we can deal with the quadratic equation. So you wait more for other examples which shall be worked out critically.